We'll proceed in innovative approach in calculus, and we will see the differentiation or integration of sin x without the first principle. The first principle of differentiation says that if I have how to calculate differentiation of a function fx. Differentiation of a function fx is nothing but fx plus delta x minus fx by delta x. Fx plus delta x minus fx by delta x, that is the differentiation through first principle. What it talks about is, okay, now consider this is the fx and this is x-axis. This is x-axis and this is fx. If this is fx, or I can take it out, consider this is x-axis and this is fx. This is x-axis and this is fx. In that sense, at any point at x, or I believe this is better. Okay, this is or okay, this is better. Okay, this is x-axis. This is function over x. This is a curve. At point x, this is fx, that is the height. At point x plus 1, this is new fx. If x, or consider this is point is x1. This point is x1. Another point is x1 plus 1. At point x1, the height is fx1. At point x plus 1, there is another height. What is difference in height we are seeing when I move x from x1 to x1 plus 1? If there is one unit change along x-axis, then how many unit of change I see along y-axis? That is dfx by dx at x equal to x1. This 1 is not 1 meter, 1 centimeter, any one unit. If that is the sense, if I have x equal to x1, and this is x1 plus delta x equal to x1, this is x1 plus delta x. If that is the case at x1, this height is fx1. At x plus delta x, height is fx1 plus fx plus x1 plus delta x. x1 x1 plus delta x, x1 plus delta x. At this, what is the height? At this, what is the height? What is change in the height I see when I move delta x unit along x-axis? That is fx plus delta x, I mean dfx by dx at x equal to x1. Same thing. At x equal to x1, what is dfx by dx? Dfx by dx is nothing but fx1 plus delta x minus fx1 divided by delta x. If from x1 point, if I move delta x along x-axis at x1, what is the height at x plus delta x, x1 plus delta x, what is the height? If I subtract these two heights, that height difference I am seeing when I move delta x along x-axis, dfx1 plus delta x minus fx1, I'm sorry, fx1 plus delta x minus fx1 divided by delta x. If that is the case, I can replace x1 with x, dfx plus delta x minus fx by delta x. This is the differentiation rule. Change in change, I mean change in y-axis with respect to one unit of change in x-axis, dfx by dx, or dfx plus delta x minus fx plus delta x minus fx by delta x. If I am trying to calculate the differentiation of sin x, then sin x plus delta x minus sin x by delta x. That is the case, then it is sin x cos delta x plus sin delta x cos x minus sin x divided by delta x. If that is the case, then sin x cos delta x, since delta x tends to 0, then it becomes sin x plus Sine delta x cos x minus sine x. Sine x gone. Sine delta x cos x by delta x. Sine delta x by delta x. Sine delta x. When delta x tends to 0, sine is delta x also tends to 0. By delta x tends to 0, by means anything near to 0, they look similar, so it becomes 1. So differentiation of sin x is cos x. This is what we don't believe in. Differentiation of sin x is cos x, because this is the new way of calculating. This is the new way of calculating the kind of derivative. The new way of calculating the derivative. What can be other way? Okay, we will see derivative. What is the basic calculus? Basic calculus, we have always talked that basic calculus is integration, not the differentiation. And basic mathematics is addition. So calculating the addition through the area is integration. Integration is nothing but calculation of addition through area. As I have always given example, that a person, there is our graph, x-axis is hour and y-axis is kilometer. Now a person is walking, and in first hour he is collecting or he is walking 3 kilometers. Next hour duration, he is walking 4 kilometers. In next hour duration, he is walking 2 kilometers. How many kilometers he has walked? 3 plus 4 plus 2. If he has walked 3 kilometer, 3 kilometer, 3 kilometer, 3 kilometer, 3 kilometer for 5 hours, same 3, then how many kilometers he has walked? Then 3 into 5 or 5 into 3, multiplication. Addition is nothing but multiplication only, repeated addition. 3. If I add any repeated addition 5 times, n number of times, it is same as n into 5. 5 into 3, 3 into 5. This is multiplication. But if addition is not repeated, is there any way to calculate the addition? So consider that now let's draw it. So this is origin to 1, 3, 1 to 2, 4, and 2 to 3, 1. This is the graph he is making. How much distance he has traveled? Calculate the area. Simple. So first area 3 into 1, 3. Next area 4 into 1, 4. Next area 2 into 1, 2. Then it becomes 4 into 4 plus 3 plus 2. Then it will become 9. Why you are doing this much, taking this much pen? Just calculate 4 plus 3 plus 2. 3 into 1, 4 into 1 and 2 into 1, calculating the area. It really makes sense. Trust me. Okay, like consider the granularity. What we are taking is hourly basis. Consider the granularity is minute basis. Now in minute basis, in 1 minute, consider person is traveling 10 meter. In 1 meter, person. So first minute, person is traveling 10 meter. Next minute, person is traveling 12 meter. Next minute, person is traveling 8 meter. Like that, I have data for 1000 meter. I have data for 1000 minute. 1000 minute. Can someone calculate 1000 minute? Addition? Not possible. Then, okay, let's take better example. Let's take better example. Okay, the example is, then in first minute he travels 1 meter. In minute he travels something 1.2. In third 1.4, something like that. And then at 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 kind of, actually I'm trying to take sinusoidal curve, where the minute is in radian. So at pi by 2, he is covering maximum distance. So at pi by 2 time, consider he is covering 20 meter. So starts from 0, and every minute he is covering at pi by 2, he is covering 20 minutes. Then he is covering less. At pi, He's not covering anything. He stops. Then how much he traveled? That is the question. Sinusoidal curve, typical sinusoidal curve. If this is the origin and this is x-axis, this is y-axis, then this is typical sinusoidal curve. And he is, if this is minute or second, consider second. If it is second, then pi by 2, just multiply pi by 2 by 10. So pi by 2 will come around, I believe, 1.7, 3.14. So pi by 2 will come around 1.6. So 1.6 multiply it by 10, 160 second. First second distance, second, third, fourth. At 1/60th second, he is covering this much distance. Then every second he is covering less distance. And then at the pi means 314th second, he is covering, no, he is sitting. How much distance he has traveled as per the sinusoidal. Now, someone will say, now I'll calculate. Now, 340 second, 340 second, 14 second. Can someone add? First, second, third second, fourth second, fifth second. Is it possible by anyone? Not possible. 314 addition. Everywhere the net distance that traveled by the person is different. Net distance traveled by the person in every second is different. For 314 seconds, 314, if someone calculate all addition and then say at the end of 314 seconds how much distance is traveled, addition is difficult. In that sense, someone will guess that this is a sinusoidal curve in which he is covering the distances. Then what is the integration of sinusoidal? I mean, what is the area underneath? Area underneath talks about the net addition, right? That's what we have seen. Area under a curve is nothing but net addition one. Okay. Then it is area under curve. If sinusoidal is the is the curve, then integration of sinusoidal is minus cos x. Sin x is minus cos x. Now we understood it is cos x. Now from where to where he is traveling? Minus cos x. If it is minus cos x, then pi, if I take kind of pi by, oh, I'm sorry, he is covering from 0 to pi, 0 to pi. Pi is minus 1 and 0 is 1. Okay, so it is minus 1, minus 1, minus 2. Minus is outside. 2 kilometer he has traveled, means 2 is the distance he has traveled. It can be 200 meter or whatever. Okay, because depends upon what is the, how much we have done the kind of normalization in the height. Maximum height a cos x can attain is 1, whereas we are saying maximum distance he is traveling in 1 second is 12 meters. Now everywhere you divide by 12, so that normalization would happen. So maximum distance he is traveling is 12 meter in 1 second. So if he is traveling 2 meter, then 12 into 2, 24 meter he has traveled in 340 seconds. Okay, so 24 meter, something like that. So the integration is nothing but calculation of addition through calculating the area of the curve. What is the area of the curve is integration. This is what we have seen so many times. Okay, consider he is moving like ramp. He is on motorbike and it starts from 0 and then he keeps on accelerating. So every second the distance he is covering is becoming more because he is increasing his speed. At that time, what is distance he has traveled? That is nothing but area underneath this curve. So the area underneath this curve is, if the equation of this line is considered x, then x square by 2. X square by 2 distance he is traveling. If he is walking from 0 to t second, then t square by 2 distance he is traveling. Okay, so this is integration. Integration means net addition is how much. When we are trying to calculate net addition through calculation of the area, where area belongs to a graph and graph I need to draw based upon the movement or collection of the person. Collection, how much collection is happening per unit time, that will give the graph. I have to get the equation of the graph, integrate it, get the net addition. There is a numerical integration also people try. If integration is not calculatable, like to calculate the integration of sin x into log x into sin x into log x into 1 by tan square, something like that. Then square x 1 minus x x minus sin x to the power minus 3 by 2. So much. Now no one can calculate this integration. Then people, what they do is, for every different x, they draw a graph based upon the equation, and they divide this graph into 50 part, 20 part, 10 part, whatever it is. Everywhere they take the height, okay, and they add the height and they add the height. They take 10 part and they add the height. So height, if it is okay, I believe this is this way only. Okay, so if I divide it into 100 parts, 100 sections, okay, then each section, what is the area? That is the integration, right? But someone will say, if I take less section, then less count will come. Not true, because width will be more. Here width will be very small. Width into height, that is one area. If I divide into 100 section, one section area is height into width, very small, 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 small. It will give fine. But actual integration gives very high granularity, because it is algebra, right? It may between point 1 to point, between point 0 1 to point 00, I'm sorry, between point 0 1 to point 0 1 plus point 0001. Again, it gives infinite section in between it. So that is integration. Calculation of area. To calculate the, when we calculate the area, we get the net addition. Anyway, we are in procedure to calculate the differentiation of sin x, that I can calculate while calculating the integration of sin x. That is the question. How I can calculate integration of sin x? Now, integration of sin x is not possible. Has anyone proved the integration of sin x? Generally, people go by the first principle of derivative, or consider that I have a problem that I need to calculate integration of sin x. I need to calculate integration of sin x. That is required. What is integration of sin x? People would say that is reverse of the differentiation, and calculate the differentiation of of something that will result in sin x. Then integration of sin x, anyway you calculate. Then typically people go for differentiation of cos x. What is differentiation of cos x? Cos x plus delta x minus cos x by delta x. What is cos x plus delta x? Cos x cos delta x minus sin x sin minus sin x sin delta x minus cos x. I believe so. This is like that. Cos x cos delta x. I've never tried. Minus sin x sin delta x. This is the kind of, and then minus cos x by delta x. Now, cos delta x is 1, because delta x tends to 0. Cos x gone. Minus sin x sin delta x by delta x. Sin delta x by delta x tends to 0. 1 gone. Minus sin x. So if derivative of cos x is minus sin x, then integration of sin x is minus cos x. Can someone find integration of sin x without, anyway, first principle cannot be applied in integration. Is it possible by anyone globally, he can find the integration of sin x without first principle or whatsoever? So to calculate that, we take kind of polar way. I'm not talking about polar coordinate system, polar way. Now, what is polar way? Consider this is a circle. Consider this is a circle. If this is a circle, then this is x-axis. This is a circle. then this is x-axis. The circle is centered at the origin. This is x-axis. Now consider, if this is x-axis, then this is theta angle. It is making, this is radius. This is radius moving full 2 pi degree. Now at any moment, this is at theta degree. Any moment, this is at theta, radius is at theta degree. If that is the case, then this height is h. Okay, this is the radius that is moving. At any point, it is angle theta. If angle is theta, then this height, what is seen, this height is h. Okay, at the any moment, this is at angle theta. In that sense, this is height h. What is sine theta? That is h by radius, where radius is constant. If I move, see, if I am here, h is nothing. If I move theta, height is changing. Can you see? But radius remains same. Now, at any angle theta, height is h, radius is this. Sine theta is h by r. Sine theta equal to h by r. What is integration of sine theta? Sine theta d theta is the integration of sine theta. Anyone will say quickly, what is integration of sine theta? Sine theta d theta. Sine theta d theta is the integration of sine theta. Okay, can you please calculate? Okay, I'll calculate. Sine theta equal to h by r. H by r d theta. This is our proof. It is not available anywhere else. Calculating the integration of sine theta with simple norms, not through first principle derivative. Okay, please do support us. +91 is the India country code. 9483160610. +91 is the India country code. 9483160610 is the telephone number. Anyway, now the sine theta d theta is the integration. Sine theta equal to h by r d theta. D theta someone can write as dh by d theta can be written as dh by dh into d theta. Same thing, right? Sine theta d theta is sine theta. Sine theta dh by dh into d theta. Same thing. That is nothing but sine theta is h by r. H by r, where r is constant. H is variable. H by r dh into d theta by dh. Makes sense? I have to just integrate h by r with dh into d theta by dh. This is our proof. Okay. Now what about d theta by dh? That is under. We will talk about it in bigger detail. I am not running away. Anyway. Now, now consider that we are here and this is the radius. This is the radius, and that radius we are at angle theta at any moment. This is the height. Now consider I move delta theta. This is theta, and I moved little bit delta theta. This angle is theta plus delta theta. This is theta. This is theta plus delta theta. If that is the case, this is theta. This is delta plus theta plus delta theta. I move. If that is the case, this is the previous point where angle was theta, and this is the new point. Now, what about this arc? How big this arc is? How big this arc is? Where the angle for this arc is d theta. This arc is r d theta. Arc is r d theta. If arc is r d theta, then this is the arc, small arc, and I mean this is the arc. Now since d theta is very small, this curve is equal, this straight line that is connecting these 2 points of the d theta is also d theta. I don't like this, but we will go through and we will see many hitch hatch here. Anyway, now this is the x-axis, this is angle theta, and this is height h. This is height h. Now I move delta theta. If I move delta theta, this arc, the circle arc is r d theta. That is the arc, r d theta. This is height h. If this is r theta, the line that is connecting these 2 points is also r d theta because d theta is very small. Consider this much only. For time being, consider this much only. So if this if this is the base, and if I are going like this is angle theta, this is the height h. I move delta theta. In that sense, this new arc is r d theta. Old arc is r theta. New arc is r d theta. The net arc from x-axis is r theta plus d theta. If it is r d theta, then this is the point and this is the point. If I connect through a straight line, that is also r d theta tends to r d theta tends to 0. It is very small. I can consider as the same line. For time being, just consider this. If that is the case, then if this is angle theta and this is the height h, if I move like this, then this is at new height. This height is new. This is old height h. Okay. Now this is our proof. This is height h. Now if I move like this, then it moves radius. Now this is the new height. This is the old height. Their height is 0. Height is 0. Now this is the new height, that is h at angle theta. If I move delta h, then this is the new height. Can you see this height and this height is bigger? Okay, if this height is bigger, how much change I see? Because of delta theta, there is change in delta h. Okay, so delta h height increased because there is a change in theta, that is d theta. If that is the case, now consider that here, okay, now consider that this is the first point, then this is the vertical line, then this is the vertical line. Now consider that this is now this is x-axis and this is angle theta and this is the vertical line. Now this moved d theta more. Now this is new vertical line. Okay. Now go with the old vertical line, and this is the new vertical line. There is a delta change in the height, that is delta h. If I go back, if this is the h, then I can say this is h plus delta h. Makes sense, right? Okay, this is h, then full height is h plus delta h. That is nothing but this much. This height this is the new height, I dragged it to the old height. Okay, if that is the case, then this is h and this is delta h. Okay, now if that is the case, someone can draw it. So if that is the case, then I'm talking about a new triangle. I am able to trace it. So this is old triangle. If someone draws like this, then this is the height. I'm sorry. Okay, someone draws like this. Okay, someone is drawing like this. Then if someone is drawing like this, then if he is moving theta, hope. If someone is moving theta and this is height h, this makes a triangle. Now, if I'm talking about it moves like this, then there is a delta h like this. Then and this is the curve. This is the curve. Okay. So now this is the curve. This is delta theta section. If this is delta theta section, from this point, if this is from this point, old point, if I do like this, and this is the delta theta, one point of delta theta, this is x-axis, this is the first point, that is theta angle. Then from here I moved, and this is another point, that is d theta or theta plus delta theta. This much is the curve that it achieved while moving delta theta. Now this is the height h. Now from this point and this point, if I connect like this is the old point with angle theta. This is the new point with angle theta plus delta theta. From here, if I draw a vertical and from here I draw a horizontal, it makes a triangle. Can you see? And another line is line connecting this point and this point. This length is r d theta. This is what approximation we have made. This length is r d theta. Then this length and this length. This length is delta h. This is h. This is delta h that is achieved. Okay, because same height. Delta h r d theta. Now this is a new triangle that we are seeing. This point and this point. This point is the beginning point theta, and this point is the end point theta plus delta theta. This is the line connecting, and this is the curve arc of the circle. Length of the arc of the circle, because this section belongs to angle theta. If this section belongs to angle theta, then this length, curve length is r d theta. If d theta is very small, I can, for my timing I am considering this length is r d theta. Now this is another triangle. This is another triangle where this height is delta h. If that is the case, then this angle is 90 degree. Okay, if that is the case, what about this angle? What about this angle? Now this is more or less is a tangent at this point, because delta theta is very small. This is like a tangent at this point. If it is tangent at this point, okay, then there is a radius. Now what is the old triangle? Okay, if this is x-axis and this is theta angle, then this is the old triangle. This is old triangle. If this is old triangle, from this point, this is the old height h. This point, at this point, now I have another triangle where this is radius and this is the height h and this is the delta h. So this is radius, this is radius, and this is the tangent at the radius. This is old triangle. Can you see? This is height h, this is height h, and this is old triangle. Whereas this is delta h, and this is the new triangle. If that is the case, then what about this angle? This angle plus 90 degree and this angle is 180 degree. Same as the old triangle. Old triangle is also 180 degree. Can you see? Old triangle, if I take, then this angle is 180 degree. Okay. Now, if I take new triangle, okay, then this angle and this angle, that is 90 degree, and this angle is common between the both triangle. This is 90 degree, that is this much. So if this angle is theta, this angle is also theta. This angle is theta, this angle is theta. Means for the new triangle, someone can draw it. So if this is the circle and this is the delta theta arc we are taking at this point, one height is there delta h. At this point, there is another line. This is a triangle where this length is r d theta, this angle is theta, same as the old theta. So if this is theta and this is delta h and this is 90 degree, then this is hypotenuse and this is base. This is theta. So cos theta is delta h by r d theta. Cos theta equal to delta h, that is the base, by r d theta. That is cos theta. Now what is our old integration? We try to calculate integration of sine theta d theta, that turned into h by r dh into d theta by dh. H by r dh into d theta by dh. Sine theta is h by r. 1 by r I can keep outside. Now it is h dh, d theta by dh. Now here we have cos theta equal to delta h by r d theta. D theta by dh. If delta h tends to 0, delta theta tends to 0, d theta by dh or delta theta by delta h equal to 1 by r cos theta. So d theta by dh equal to 1 by r cos theta. Now I can replace here 1 by r cos theta. Now it is h by r. R I keep outside. H by r cos theta dh. H by r cos theta dh. Okay, r again I keep outside, then outside it is 1 by r square. H by cos theta dh. What is cos theta? The square root of 1 minus sine square theta. Sine square theta is nothing but h square by r square. That is the case, then h by square root of r square minus h square, r would go top. Outside I have 1 by r square, 1 r will go away. Now it is 1 by r integration of h by square root of r square minus h square dh. This is our proof. Very solid. Okay, it will be more solid slowly. Anyway, so h by square root of r square minus h square dh. The integration of this is minus a square root of r square minus h square. Anyone can calculate. Minus a square root of r square minus h square, if someone is, this is the integration, if someone differentiated, then it becomes minus 1 by square root of r square minus h square minus 1 by 2, 1 minus 1 by 2 r square minus h square to the power minus 1 by 2 into minus 2h. Okay, minus minus gone, 2 gone, h by r square minus h square to the power minus 1 by 2. Same thing. So integration of h by square root of r square minus h square is minus square root of r square minus h square. I can keep minus outside. Now minus 1 by r is outside. Now here we got integration as r square minus h square square root. Okay, now r I can place here. If r go inside the square root, it becomes 1 by 1 minus h square by r square square root. H by r is sine square, sine theta. 1 minus sine square theta square root. Minus is outside. So 1 minus sine square theta square root is cos theta minus cos theta. Integration of sine theta is minus cos theta. Mind blowing, right? Mind blowing. What is the approximation we have done? That is the arc length, same thing we put as the line connecting the two end of the arc. Whatever the line connecting two end of the arc, that length same as arc length we took, that is r d theta, considering d theta is very small. Now we will see now that what is the kind of this approximation cannot be in air. This is what we hate, right? Approximating delta x tends to 0, and then we start from there. If I don't approximate delta x tends to 0, or if I am approximating, then there is a chain that I am seeing here. There should be opposite chain somewhere else to kind of compensate this approximation. So this is assignment for people, that can you see, if I am approximating r d theta arc length to the line connecting as r d theta length, then where this approximation equivalent in opposite direction, where change is happening, that is compensating this approximation. Someone has to think about it, and that we will see. Please do support us.